Hi everyone, good evening. I hope I am audible. Welcome to the 11th live session, or sorry, 10th live session of the course Network Analysis conducted by IIT Kharagpur. Today we'll be looking at assignment 11. So, assignment 11 is a continuation of the two port theorems that we saw in the last week, that is of assignment 10. And I hope this assignment, looking at this assignment, it will help you to solve the current week's assignment. So let's start. I'll be sharing my screen. So I hope my screen is visible and you are also able to hear me at the same time. Okay. So let us look at the question. So as I told you, this assignment 11 is a continuation of the assignment 10 of the previous week, that is two port theorems. So let us look at the problems one by one. The problem of this week would be a bit different compared to last week. So last week was straightforward, right? You were already given some circuit and you were told to find out what are the Z parameters, H parameters, this, that, right? But here in this week, you can say it's a application of the two port. So you won't be directly told to calculate the two port parameters. Instead, you would be using that to find some other things, right? Other like currents or voltages. So, for instance, if you look at this circuit here for question 1 and 2, they have told that there is already a two-port network with Z parameters which is given, and to the port 1 of this network, we have a resistance and a voltage source connected, and also to the port 2 we have a 20 ohm connected, and the values of the voltage and current, I mean they are indicated, so V1 I1 and V2 I2, right? So now we need to find out what are the values of I1 and I2. So in order to do that, so let's start. So the Z parameters are given. It's 20, 35, 35 and 50, right? So basically, if you remember the formula of Z parameters, it was like V1 equals to Z11 I1 plus Z12 I2, and V2 equals to Z21 I1 plus Z22 I2, right? Now we have to use this part here. So we need to write a KVL equation for this mesh and also for this mesh here, right? So what is the KVL equation for the first mesh? On the left hand side, it's nothing but 20 equals to 10 I1 plus V1, right? Because we have a voltage source of 20 volt here and the resistance is connected, so a current would be flowing which would cause a voltage drop of 10I, and then we have the potential across this Z port, right? Z two port network which is V1. So this is the equation, and so let us rather call it as equation number 1. And what would be the second equation? It is at this mesh here. It's nothing but V2 equals to minus 20 I2. Why minus 20? I mean, why minus? Because you see the current is flowing in the direction opposite to the potential of V2, right? Because normally it would flow from positive to negative, but it's flowing from negative to positive, the opposite direction. That is why this minus is there, nothing else. So let's just substitute the z parameters in this equation. So this is V1 equals to 20 I1 plus 35 I2, and V2 equals to 35 I1 plus 50 I2, right? Now what we will do, we need to find out what is the value of I1 and I2, right? So what we will do, we will just substitute the value of V1 and V2 in 1 and 2 equation. So let us call this equation 3 and equation 4. Now we will write substituting V1 from equation 3 to equation 1, or rather in equation 1. So therefore it would become 10 I1 then plus 20 I1 plus 35 I2, right? So the resultant equation would look something like this: 30 I1 plus 35 I2. If we just cancel 5 from each side, so it's like 6 I1 plus 7 I2. Right? And in the similar way, we can substitute V2 from equation 4 in equation 2, right? So as a result, what this would become, so V2, we are substituting V2 equals to minus 20 I2. So basically 4 in 2, right? So this, as a result, this would become 35 I1 plus 50 I2 equals to minus 20 I2, right? So this is 35 I1 equals to minus 70 I2. So therefore I2 equals to minus I1 equals to minus 2 I2, right? And now again we have a lot of equations actually. So let us call this 5 and 6. So now a simple substitution of, so substituting I1 from 6 in 5. So this would become what? 4 equals to 6 into minus 2 I2 plus 7 I2, right? So this would become minus 12 plus 7 is minus 5 I2, right? So I2 as a result would become minus 4 by 5 amperes, which is your 0.8 amperes. And so what would be I1? It would be just the double of this, right? And also a minus is here. So this is 8 into minus 2, right? You can skip the minus. So it is 1.6 amperes. So as a result, your this is one answer, and this is the another answer. So the for the first question, basically for the first part, you have two answers to find, I1 and I2, which is 1.6 and minus zero point 0.8 amperes respectively. So just a minute, let me pull it down. Stop. Yeah. So If you have any doubt or you want me to explain again, you can tell me. I'll do so. If you haven't understood anywhere. So this is a very simple problem. We just need to implement the equations. We need to write the KVL for this mesh here and also the mesh here, and then just substitute the values. And we are also given the z parameter values. So using that, we can directly get the values of I1 and I2. So I hope this is clear. If you have any doubt, please do let me know. I will clarify. Okay. So if you don't have any doubt, let's move to the next question. So here, see, you have what? Uh, there is a inner. So basically, there are two port parameters. One is this inner Z parameter circuit. I mean, two port circuit. Inside two port circuit is there. So basically, its Z parameters are given, and on the outside there is another two port parameter, right, which is encircled in this box where you see these resistances are given, right? So they have told that in the above circuit the Z parameters of the inner two port network is given. So they have told us to determine the overall Z parameters of the outer two port network, right? So uh, I mean, let's start. So basically, we need to write the KVL equation for this mesh here, and also the KVL equation for this mesh here. Okay, that's the one. Yeah. So we will go slowly. So if I break this part, so the part on the left hand side, if I break this part into something like this, so I'm just redrawing the circuit in a closed loop manner. So this is my 10 ohm resistor. This is the 10 ohm resistor. This is the voltage source, which is V1 dash, right? And this is the 20 ohm resistor, and then this is again plus V1, right? Where the inner Z, I mean, there is another two port network which is here, right? So this is the two port network whose Z parameters are already given. So now we can write and it's also given that through this, basically your I1 is flowing, right? Current I1 is flowing. Now using this, we can easily frame a KVL equation, right, in this mesh. What is this? Pretty simple. So this is V1 dash equals to 10 I1, then your V1, right, plus 20 I1. So as a result, the equation becomes 30 I1 plus V1, right? In the same way, there is again, I mean, if I again redraw the circuit here, the right hand side I'm drawing again. So there is this potential which is V2 on the right hand side. Again, there is a resistor which is 30 ohm, and there is a resistor which is 40 ohm, and there is a potential voltage source of V2 dash, right? Now on the left hand side again, this two port network is there. right? And it's already given that through this mesh I2 is flowing. So using this we can easily frame another KVL equation. So V2 dash equals to 30 I2 plus V2 plus 40 I2, right? So V2 dash equals to 30, sorry, not 30, it would be 70. 70 I2 plus V2, right? Now let these two equations be I1 and I2. I'll just stop here to understand from you guys whether you got this or not. If you have any doubt, please unmute and speak. I can clarify. I mean, how did we get these equations? If you don't understand, then please do let me know. Guys, did you understand?
Yes, sir.
Okay, okay, okay. So, if you have understood, then the next part is pretty simple. So now we need to write the equation for. So what is the Z matrix here? It is nothing but 50, 60, 80, 70. So we can. So this is Z inner. I should rather write this is Z inner, right? So now we can frame another set of two equations. So V1 equals to 50 I1 plus 80 I2, right? And it's, I mean, by default it's already it is already shown that uh, I mean, within this two port, inner two port network, current I1 is only flowing, right? Because as you can see through this, so if we just consider this as one port here, right? So this is the inner first port and this is the inner second port. So it's already given that I1 and I2 are flowing. Therefore, that is how we are writing 50 I1 plus 80 I2. We are not writing some other currents, right? So, I mean, the currents are same. So, in the same way, it's 60 I1 plus 70 I2. So, now again, let us call it 3 and 4. And now what we will do, we will substitute V1. So, substituting V1 from equation 1 in 3. So it would be what, V1 dash minus 30 I1 equals to 50 I1 plus 80 I2. So this is what V1 dash is, 80 I1 plus 80 I2. And in the same way, we also do the same for V2 also. So substituting V2 from equation, it is equation 2 in 4. So this would be what? This would be V2 dash, no, sorry. Yeah, okay, fine. V2 dash minus 70 I2 equals to 60 I1 plus 70 I2. So we are basically substituting this here, uh, I mean this into this, right? So V2 would be V2 dash minus 70 I2, that is we are substituting here and we are getting this equation. So resultant final equation would be, sorry, this would be 60 I1 plus 140 I2. So as a result, what would be our Z matrix? It would be, so Z outer I mean, if you consider this equation and this equation, because that is what they have told. If you consider this as a whole, as a two port network, so this is what our voltage equations are: V1 dash, V2 dash, I1 and I2, right? The voltage and current parameters. So as a result, the Z outer would be what? It's 80, 80, 60 and 120. So here you need to separately write these. So this is your Z11. So basically Z11 out, Z21 out, Z12 out, and Z22 out. Right. So this is your answer. So this is the answer to the second set of questions. I hope this is clear, guys. Again, if you have any doubt, please do unmute and speak.
Yes, sir, clear.
Okay, fine. Manikananda, it's also clear to you, right?
Yes, sir.
Okay, thank you for responding. So let me again pull this upwards a bit. Okay. So now, please, I mean, understand this question carefully. So this is, so basically here there is one network, network one, and here there is another network, network two, right? So now they have told us. So the first set of questions is easy. So question 7 to 10. This is easy because why they have told us to determine what is the y parameter of network one, right? So we just need to apply v1 equals to 0, v2 equals to 0, and then determine what is the y11, to 1, 1, 2, and 2, 2. But now you see here, here they have the two networks, I mean network one, right, which is connected in what way? So this is connected how? Are they connected in series and parallel? Can anyone tell me? Because we need to derive what is the equation of this kind of two port networks, where one network is connected with the other. We need to derive, and then finally we will be able to solve question 11 to 14. Otherwise you can't solve. So in order to solve this, you need to understand how this is connected, whether this is a cascade connection, series connection, or a parallel connection. So can anyone tell me how is this
Parallel
connected?
connection, sir.
Why? How, I mean, how are you telling?
Because current entering through each network is independent, sir.
Yeah, it's correct. Yes. See, because I mean it's visible now. I mean the port one, right, of both the networks. You see here one and one. This is connected to the port one of the outer circuit, right? And similarly, port. I mean this one dash is also, so this one dash and this one dash are also connected together, right? So that is why how, so basically here you can say this current will get divided into I1 dash and I2 dash, right? I1 dash and I1 double dash, right? So basically here this current gets divided into two parts. So that is how you can say that these two networks are connected in parallel. So this is very important to understand. If you don't understand this, by mistake, if you consider this as a series network, then you will not arrive at the right answer. That is why I asked. Anyways, so let us now solve. First, we need to determine what are the y parameters of the initial circuit. Right? What is happening? Right. Okay. So let us now draw the circuit once. Then we will start. So this is point 0.5. This is point 0.2 and 0.25. This is port 2 V2, I2, I1, and V1. Right. So what is our y parameter? So it's nothing but I1 equals to Y11. It's impedance, right? Sorry, admittance, inverse of resistance. So that is why it's y, right? So as a result, we need to first put V2 or V1, whatever you may want to use. So first we will short the terminal 2, right? V2 equals to 0 means current is infinity. So we need to short it. And as soon as you do that, your this thing will get shorted, and as a result, this 0.25 resistance will get nullified, right? So this is 2, this is again I2, this is I1, and this is V1, right? Now you can apply a simple KVL in these two loops, right? So V1 equals to um, 0.2 your I1 plus 0.2 I2, and KVL in the second mesh is 0.5 I2 plus 0.2 I2 plus 0.2 I1 equals to 0. So uh, basically it's zero point 0.7 I2 is minus 0.2 I1, right? Uh, so now what we will do, we will just substitute this thing here. So what we will do, or let us write it like this: 0.2 I1 equals to minus 0.7 I2 here. So this becomes 0.7 I2 plus 0.2 I2. Right? So V1 is minus 0.5 I2. Therefore, I2 by V2 is minus 0.5, which is ohm inverse, which is minus 2 ohm inverse. And this is your Y. I'm sorry, this is V1, right? So basically, this is Y21. So Y21 is minus 2 ohm inverse, and similarly, um, so we need to substitute I2 equals to minus 2 V1 back to this equation here, right? So 0.2 I1 equals to minus zero point 0.7 into minus 2 V2. This is V1, sorry. Right? And so this minus minus gets cancelled. So I1 is zero point 0.7 into 2 by 0.2. So this gets cancelled. And this is V1. So it's 7 V1. So I1 is equals to 7 V1. Therefore, your uh, Y11 is I1 by V1, it's 7 ohm inverse. Okay. So this is the first part. Now we need to do V1 equals to 0, right? So V1 equals to 0 means this part will be shorted and this point 2 will get nullified, right? To pull it downwards from in. So V1, so this is V2, this is I2, this is I1, this is point 5 and 0.25. Again same thing, KVL. So V2 is 0.25 I2 plus 0.25 I1, and in the second one it's 0.75 I1 equals to minus 25 I2. So we will just substitute this in this. So as a result, what this equation becomes 0.75 I1 plus 0.25 I1. So this is 0.5 I1. So Y12 would be what? I1 by V2. This would be Y12 would be minus 2 ohm inverse. And now what we will do, so basically from this we can say I2 equals to minus 3 I1 because 75 by 25 is 3, and we now just need to substitute this because I1 equals to minus 2 V2. So I2 would be 3 into 2 V2 minus. So this is 6 V2. Therefore, Y22 is I2 by V2. It's 6 ohm inverse, right? So therefore, your what is your Y matrix? It's what is Y11? It is 7, right? So this is 7. This is minus 2. This is minus 2, and this is 6. So basically, this is your inner Y matrix that we have just found out. Now we will proceed to the next fourth set of questions. So I hope this is clear, guys. I hope this is clear. If you have any doubt, just speak up. Anywhere you did not understand. Okay. So if this is clear, now we will derive what would be the equivalent Y parameter of these two circuits. So as you saw, and we will do it in a separate page. So I will just open up a new section here and then we will try to do it. So as you saw that these two networks are connected in parallel, right? So in a parallel network, the voltage of the equivalent, I mean across both these two networks would remain the same and the current would get added. So this basic thing is required. So we will try to quickly redraw the circuit here. So this is network 1 and this is network 2. So this is one port, this is another port, sorry, this is the same port. And this is connected to this, and this is connected to this, right? In the same way, this is connected to this, and this is connected to this, and this is the equivalent circuit, right? So this is I1, Let us call this V1, and this is I2, and let us call this V2, right? And let us just enclose this in a bracket, in a box, sorry. So this is the I mean black box, or another network you can call, right? So here, yeah, so here, let me use different. So let us say that this I1, this is getting divided into two currents here. So let us say this is I1 dash, and this is I1 double dash. In the same way, I2 dash and I2 double dash. So now, see, if V1 is applied to the total circuit, and if this is a parallel circuit, so in a parallel circuit, same voltage is applied across both the networks, right? So the potential across network 1 would be V1 at the left hand side and V2 at the right hand side, same for network 2 as well. So we can directly frame what you call y equation, I mean y parameter, this thing as we saw. So that's for I1 dash. So what would be I1 dash? It's V1, right? Let us call this as y11 dash, right? And this would be what V2 y12 dash. And okay, so before in proceeding, so network 1 ka y parameter is y11 dash, y12 dash, y21 dash, and y22 dash. Okay. Similarly, network 2 would be, so let us just call this as y double dash. So y11 double dash, y21 double dash, y12 double dash, and y22 double dash. Okay. So having done this, now it would be a bit easier for you to understand. So in the same way, we can also write this I2 dash equation at the right hand side of network 1. So this is V1 Y21 plus V2 Y22 dash. Now in the same way, for network 2 also we can write. So I2 dash is what, or not I2 dash, sorry, I1 double dash. I1 double dash would be what, same voltage again, right? V2 Y12 double dash, and this is I2 double dash is V1 Y21 double dash plus V2 Y22 double dash. So these are the two sets of equations that we got. I'll just stop here. If you have any doubt till this point, please ask. Any kind of doubt you have. Hello, guys, did you understand?
Yes, sir.
Murshid, you understood this? Okay. I hope you guys are on the call. Okay, fine. So now since we got this four equations, now what we will do, so see, we already saw, I mean, since this is a parallel circuit, so we can say that I1 equals to, I mean, if we apply nodal analysis, it's I1 equals to I1 dash plus I2, I1 double dash, right? So simply I1 is I1 double dash plus I1 dash plus I1 double dash, sorry. So therefore we will just substitute these two equations here, right? So I1 equals to V1 1 plus V2, sorry, this is Y12, right? And again V1 Y11 plus V2 Y12 double dash, right? So now it's like if we take V1 common, right, because it's a parallel connection and it's the same voltage, so it's something like this. And V2 would be what? Y12 dash plus Y12 double dash. In the same way, if you do this, for the second equation, it's like I2 equals to I2 dash plus I2 double dash, right? So now if you substitute these two equations in this here, you will get something like this again. So V1 is Y21 dash plus Y21 double dash plus V2 Y22 dash plus Y22 double dash, right? So isn't this another y, I mean parameter equation? So can't we write it like this? I1 in a matrix form. So something like this basically. And here we have V1 and V2, right? So as a result, so this is our net y equation, right? Y matrix. So can we can also break it like this, right? So this is what y11 dash, y21 dash, y12 dash, y22 dash plus simple matrix addition operation, right? This is right. So this is our net equivalent. Um, this thing y parameter equation when you have two ports connected in parallel. See, if you have this kind of equation, you can also use z parameter, right? But it in this case, it would be something like this. So you would be obtaining this. So this would be z1, z21 dash, z12 dash, z22 dash, but this would be inverse of this. And along with this, remember, because y is admittance, it's ohm inverse, and z is impedance, it's ohm, right? So that is why this inverse is coming. So that is why this inverse is coming. And initially, if this was a simple series circuit, okay, so basically this thing here, it, I mean, if this was a simple series circuit, then it would have been the addition of the two z parameters of the circuit, okay. Since this is a parallel circuit, so that is why, current gets added, and that is why in a way we have this y parameters getting added. So this is the derivation. Now we can simply, apply this in the problem, and then we'll reach the answer, get the answer. So I hope this is clear, this derivation, the way I showed it. I hope this is clear. If you have any doubt, please do ask. Okay, if you don't have any doubt, good. So basically, now we need to just add this. So basically, this is our y1 since the same network is getting. I mean, they are connected in parallel. So basically, it would be the addition of this. So this is our y1. This is again our y2, right? So our net y, so y equivalent or y net is nothing but y1 plus y2. So 7226 plus 7226. So this is 14 minus 4 minus 4 and 12. You were told to find out. Okay, so this is how you solve this problem. All the so this was for the initial circuit network 1 and this is for network 2. Okay, so these are the answers, guys. I hope this is clear.
Sir,
Yeah.
sir, this problem you teach that was clear, sir. But I have one doubt.
Hmm. Hmm. Hmm.
If instead of impedance value, if they uh, given us admittance now, what will be the answer, sir? We
I
can
did not.
directly convert.
This is admittance value. So this is
No, sir.
only
The
admittance.
answer is admittance value, sir. In the question,
Ha ha.
we are
Yes.
having resistor value. I mean resistance value, correct, sir, in ohm.
Okay.
If they given in a ohm inverse means we need to convert into ohm.
Hmm. See, if I got you properly, you are talking about this value, right? So if they have given it in
Yes, sir. In
ohm
the
inverse,
question. Yes, yes, sir.
no, they won't give you like this because that is not a
Sir,
proper way to write. Bolo.
sir, in this week we are having that type of problem only, sir.
Oh,
Sir,
okay.
I converted that and I done in this week, but I want to make sure that it's correct or not. So only I'm asking, sir, to you.
It is right. See, if this is a resistor and it's given in ohm inverse, it's you need to inverse it and get it in ohm. Yes, that's true.
Okay, sir. Sir, while we do with the ohm inverse means at the last we need to convert whatever the y parameter we are getting, that we need to
Hmm.
convert into ohm inverse, correct as well? From ohm to ohm inverse.
Wait, finally, when you get the Z matrix, I did not understand. When do you need to convert?
Sir, initial also initial conversion, okay, sir.
Uh,
If we do without conversion means we will get Z parameter, correct as well?
no, you need to write the y parameter equation. Na? If you do like this, then you can do. See what I did. Instead, see here. If I do v1 by I2, I would get what z21, right? But instead, I'm doing I2 by v1. You need to just be careful of that. If I do like v1 by I1, I would get z11. But I'm doing I1 by v1 because I need to find out y parameter. So you just need to do this. That will
Okay, sir.
be sufficient. You don't
Okay,
need
sir.
to find out the Z matrix, then do the inverse of that. That would be more complicated. You will lose time, and that would be stupidity also, right? Because you have this. You just need. That is why I told you you need to write the y parameter equation. If they have told you to write the find out the y parameters, you need to write these two equations. If they have told you to find out the ABCD parameter, you need to write the equation of that, and then do like I so v1 is a V2 plus minus B I2, right? So you need to make I2 0, then your A would be V1 by V2. So you need to do like that. So that is why writing these two equations are so very important when you solve Y parameter two port network problems. Okay.
Okay, sir.
Okay. So let me just pull this upward. So this is the last set of questions. We will try to complete this quickly. See this question now, I won't solve it. So you can find out the Z parameters of these this network, right? So in a way, if I draw like this, just let me use an here. So in a way, this is our black box, right? So this is a network. If I just encircle it here, so this is our network, right? But here we have already been given, so you can apply a two port any two port theorem you want to apply, and then you can solve this. Let's erase this thing. Yeah, so you can do that, but what I will do, I will try to solve it conventionally. I'll apply KCL direct for each of the four questions that we have been given. In a way, that would be a revision for you as well. Okay. So what I'm just trying to say is that here you can directly solve it like this. So V1 equals to Z11 I1 plus Z12 I2. Then V2 is Z21 I1 plus Z22 I2. Right. So you need to solve this and get V1 and I1. I mean this equation. You can do like that, but that will also do. But I won't do like this. We will do it conventionally. So in the first question they have told what is, we define the open circuit voltage gain AV. So any circuit has a gain, right? If you have read analog circuits, their BJT, then MOSFET, these circuits have a gain. Or in electrical, if you have studied the power electronics, may buck converter, boost converter, right? So there also we have a gain, DC circuits. So here we have to find out what is the voltage gain. So voltage gain or any gain, remember it's the output divided by the input. Now it can be voltage gain or current gain. Okay. So voltage gain would be output voltage by input voltage. That is why V2 by V1 with port 2 open circuit. Okay. So port 2 open circuit means this I2 would become 0 and this would remain open. Now let us solve this. See what you can do as an exercise. I am trying to solve this in a conventional way. You try to find out any of the parameters, Y parameter and Z parameter, and then you can try to do this. So this can be a double exercise for you, practice thing. So let us just redraw the circuit. Uh, so there was one resistor here, yeah, two resistors, one current source. This is of course a dependent current source, right? Okay. Now what are the values of this 10, 10, 10, and 2 I1? 10, 10, 10, and 2 I1. This is V2 and V1, right? Now simple, we directly apply KCL, right? So this is, of course, this is I1. So this is node 1 and this is node 2, right? This is pointing upwards, right? Sorry, this is pointing upwards, right? Yes. This is pointing upwards. So uh, basically I1 would be what I1 is getting divided into these two parts. So let us say this is I1 dash and this is I1 double dash. So I1 equals to I1 dash plus I2 I1 double dash, and I1, let it be I1, then it is V1 by 10, right, because this is grounded, and this is V1 minus V2 by 10, right? So right now, um, now we, so this is node 1. Now we need to solve the equation at node 2 also. So basically, let us say this is I2 dash and this is again coming in this way. So I1 double dash is equal to I2 dash minus 2I1, and there is no I2 of course because it's 0. So and this is coming into I2 dash, right, into this path, so that therefore this is minus. So again, if we substitute, V1 minus V2 by 10 equals to V2 by 10 minus 2I1. So let us directly substitute this here, right? Substituting 1 I1 from 1 in 2. Right? So V1 minus V2 by 10 equals to V2 by 10 minus 2 into, this is the 2V1 minus V2 by 10, right? See here we are getting, we will get a value in terms of V1 and V2, right? We will get a ratio directly. So we cancel all of this. So V1 minus V2, V2, and this minus minus becomes plus, right? So 4 V1 minus 2 V2. I did make some mistake maybe somewhere. Okay. Just a minute, hold on. Oh, there is no minus sign here. No? There is already a minus. Yeah. Yes, sorry. So this is minus, this is plus, therefore this is V1 plus 4V1 equals to 2V2 plus 2V2. So 5V1 equals to 4V2. Therefore AV is what? It's V2 by V1. Therefore it's V2 by V1 means 5 by 4, which is V1. This is answer to the first part. Okay. Question number 15. Answer is 1.25. This is the voltage gain. I hope this is clear. If you have any doubt, anywhere you didn't understand, please do say. See, you can solve it using two-port network and then try to match the answer. This would be a exercise for you as well, a practice for you as well before you go sit for the exam. Right. Okay. So if you don't have doubt, let's move to the next part. So we define the short circuit current gain as AI. So we need to therefore short port 2, right? So V2 would be equals to 0. Okay. So here port 2 is now short circuited. So we need to redraw the circuit again. So, and here there is a small twist. I won't draw the 10 ohm resistor. I hope you know why. Because port 2 is short circuited. So this is I2, this is 2I1, this is I1, and this is V1, right? See, um, let me just use a different thing to quickly make you understand why 10 ohm resistor is not there. And of course, this is grounded, right? This part is grounded. See, if this is grounded, so this ground is also connected. So essentially this is our port 2, right? So this is port 2 and this is port 1, but port 2 in a way is connected to ground, right? So through this path, this shorted path, because there is no resistor. So if there is no resistor in this path, so this potential is equal to this potential. Therefore, this is zero. Therefore, no. So therefore, this would be considered as an open. I mean, there would be no current flowing through this path, right? So therefore, 10 ohm resistor won't be there. So I hope you understood this. This is pretty simple. So now let us solve the problem. Now again, let us say that this I1 and I1 gets divided into two parts. I1 equals to I1 dash plus I1 double dash. Therefore, V1, sorry, I1 is what? V1 by 10 plus V1 minus 0 by 10, because this is 0. Therefore, I1 is what? V1 by 5. And so if we apply the KCL at node 2, which is essentially 0, so this is node 1 and this is node 2. I mean, essentially 0 means the potential is 0, right? So I1 dash plus I2 plus 2I1 is equals to 0, right? So um, what is I1? It's V1 minus 0 by 10. Then you have I2 and also you have I1. So now V1 by 10 is what? It's basically 2I1, right? Because why? So let me just write it like this. So V1 by 10 plus I2 plus 2I1 is equals to 0. We can also write it like this. Sorry. So we can also write it like this, right? I did a mistake initially. It won't be 2I1. So this would be half into I1, because V1 by 5 is already I1 we found out. This is I2. This is 2I2. 2I1. So I2 is what? 2I1 plus 0.5 I1. It's 2.5 I1. Right. So AI is what? It's minus I2 by I1. Right. So minus I2 by I1 is how much? It's minus or minus 2.5. So the gain is 2.5. This is the answer. Guys, if you have any doubt here, because especially the second step is a bit complicated in a way. I mean, if you haven't understood, you please do ask this part. if you have any question. Manikananda, you understood this? Hello? Guys, did you understand this? Anyone has any doubt?
Yes,
Manikananda, Satya Prakash? Okay, fine, good.
No, sir. No.
You understood this or not? You didn't understand?
Sir, slight bit your voice cracking, sir. It's somewhat stopping. Then I'm able to hearing like that.
Now is it better?
Yes, sir. Very clear.
I am using a headphone. Actually, the mic is downwards, so that is why the voice is low. So, okay, did you understand this problem? At least the steps which I did, or if not, please do let me know. I'll explain again quickly.
Sir, once more quickly, can you explain us?
Okay, fine. In the question they have told we define the short circuit gain as minus I2 by I1, where port 2 is short circuited. So port 2 is short circuited means this is shorted, right? V2 is gone, it's zero. So we redraw the circuit here, and the 10 ohm resistor is cancelled because see, this 10 ohm resistor. So if there was a resistor here, right? So basically here, and this is grounded because we are applying KCL. So this ground or zero potential would be connected at port 2, which is all, therefore port 2 is also zero. Therefore automatically your 10 ohm resistor gets nullified, right? So now you just apply KCL at port node 1. You get so this is 0 because V1 minus V2 for node 2 ka voltage is 0, so therefore you get I1 equals to V1 by 5. Now you apply KCL at node 2. This is what I1, I2 I1 and I2, I1 double dash 2 I1 and I2 is equals to 0. You substitute, so this is V1 minus 0 by 10. I2 and I1 are the same as it is. Now so we can write v1 by 10 is nothing but half into v1 by 5, and we just found out v1 by 5 is I1, so I substituted this here, and from this we get minus I2 by I. So I2 by I1 is minus 2.5, therefore minus I2 by I1 is what, 2.5. So that is the answer.
Yes, sir. Clear.
Okay. Okay, so now going to the next question. So they have told if a 20 ohm resistance is connected across port 2, then the impedance in from port 1 would be. So here there is a 20 ohm resistor connected. So see, what do you mean by the impedance in from port 1? Impedance in from port 1 is nothing but the input impedance. So it's nothing but V1 by I1. Okay, so it's nothing but Z11 in a way, right? So V1 by I1. So now let us, having understood this, let us now solve it. So our circuit would be something like this. Just a minute. Um, is 20, 10, 10, 10, and of course there is I flowing, I2 flowing here, but we won't require it because we will be anyways applying KVL, right? So this is your port 1, this thing, this is your port 2, this is grounded. So let us apply. So node 1, not port, sorry, this is node. So I1, so let us call it like this is I1 dash and this is I1 double dash. I1, so I1 is equal to I1 double dash plus I1 dash. Okay, so I1 is what? I1 double dash is V1 minus V2 by 10, same as the previous one. So I1 is 2 V1 minus V2 by 10, right? Now what is node 2 ka equation? It is V1 minus V2, or rather let us write it like this. Just a minute. Yeah, so let us write it like this. So let us write it like I1, or like here, okay? And this is also I2, right? So this is I2 dashed, okay? So if we apply KCL here, I1 double dashed plus 2I1 plus I2 is equal to I2 dashed, right? Because all of these currents are coming into node 2. So incoming current is equal to outgoing current. Now V1 minus V2 by 10 plus 2I1, let it be as it is. Now what is I2? See, I2 is minus V2 by 10, 20, because the current is flowing in this loop, right? I mean, if we consider it like this, that I mean, I am assuming that the current is flowing into 20 ohm resistor, and it should be like that only, right? Because here there is a current source, there is also a voltage source here, so it would be driving current into this 20 ohm resistor. So having said that, I am writing minus V2 here, and of course your V1 would be I2 test would be V2 by 10, because it's this current that is flowing through this 10 ohm resistor. So this is what I1, and let us take this to the other side, V2 by 10 plus V2 by 20, and I will now substitute I1 from this to here. Okay, so V1 minus V2 by 10 plus 2 V1 minus this is V2 by 10, and this is what this would be 2 V2 plus V2 if I take the LCM. V1 minus 2 V2 by 10 equals to 3 V2 by 20. So 2, so this would get cancelled and this 2 is coming to the left hand side. 5 V1 minus 3 V2 equals to 3 V2. This is how much? 10 V1 minus 6 V2 equals to 3 V2. Therefore, we get a relation between V1 and V2, but now we can substitute this here, right? Because we need to find out V1 by I1, because here they have told us to find out what would be the resistance impedance in from port 1 if we connect 20 ohm resistor at port 2, right? So I'll just write it like this. Right, so we'll just substitute this here. So mm I1 2v1 minus 10 by 9 by 10. Okay, so 18 v1 minus 10 equals to minus 10 90. So 8 v1 by 90, right? So v1 by I1 would be how much? It's 90 by 8, 45 by 4. So this would be how much? 22.5 by 2, 11.25, right? So 11.25. This is the answer. So this is how you solve this. If you have any doubt, please do ask. Anywhere you didn't understand in this problem? Easy problem, but a bit lengthy. These steps. Did you understand this, guys?
Yes, sir.
Okay, fine. So let us now move to the last problem. So here, the reverse one. So they have told us that if a 20 ohm resistance is connected at port 1, what would be the impedance seen from port 2? So basically V2 by I2, nothing else. Straightforward. Okay, so we'll do this. So here there is a, we'll just redraw the circuit again. This is 10 20. There is a resistor here. Now here there is a small trick that you will see shortly. So this is a V2, this is 2I1, this is I2, this is 10, and here this is I1, right? So this is I1, okay, and this is port number 2, going by the same convention. This is sorry, node 2, node 1, this is ground. Therefore the potential across these 20 ohm resistors would be V1, and 10 also V1. Therefore what is I1? I1 is nothing but V1 by 20, right? Because it's flowing outwards, I mean from ground towards potential 1, right? And that is why this is minus is coming, and here this potential is nothing but V1, right? So that is why V1 is minus 20 I1 in a way. So just wrote it in the reverse format. Now let us apply KCL directly at node 2. So node 2 may, let us write it like this. So this is I2 dashed and this is I2 double dashed. So I2 plus 2I1 is equal to I2 dash plus I2 double dash. So I2 plus 2I1 is equal to this is V2 by 10 and then again V2 minus V1 by 10, right? Because there is a potential, I mean voltage source connected here. So we need to look at from the right to left. So this is 2V2 minus V1 by 10, and let us directly substitute this here. So I1 is V1 by 20, so therefore if we write it, so I2, so 2I1 my sorry, I1 it should be V1, so V1 by 20, and this is 2V2 minus V1 by 10, right? uh, this is I2 V1 by 10 and 2V2 minus V1 by 10. See, directly this gets cancelled, right? If I write it separately, 2v2 minus v1 by 10, this gets cancelled. So we are left with I2 equals to 2v2 by 10, so v2 by 5. Therefore, v2 by I2 is what? 5. So this is the answer. Much simpler than the previous problem. So you need to remember, I mean, you need to identify this. I1 is v1 minus v1 by 20, right? You need to identify this. Sorry. So this is the solution to the last question of this assignment. I hope this is clear.
Yes, sir.
Okay. So yeah, so this is assignment number 11. I'll upload the video and also this material. I hope this would be useful for your assignment 11. Right. I hope you understood the steps properly. Okay. So next week we'll meet again, and I'll be uploading the video by today. I mean tomorrow early morning. So if you don't have any other doubts, I'll close the meeting and we will meet next week again.
Bye, sir.
Okay. Thank you guys. Bye. Good night.